Hi folks, Dave here. Another video from Science for 3400, assignment number 2, question number 5. Train A starts at 4 miles south of a bridge and heads north at a constant speed of 30 miles per hour. Train B starts 6 miles north of the bridge. What velocity must train B have so the two trains cross the bridge at the same time? So as we discussed last semester, in order for two things to be at the same place, they need to be there at the same time. So time is our constant. So if I have a bridge, that's a rather plain looking bridge, and I have my train A, which is south of it, and it's heading north at 30 miles per hour. You know what, before I get any confusion, how long is it going to take to get to the bridge? 30 miles per hour, and it is 4 miles. Well, what equation do we have that has, I've got a distance. These are all A's. Distance of A is 4 miles. I have a velocity is 30 miles per hour. So when I'm looking for time, equals question mark. Well, we have an equation, S equals what? U plus VF over 2 times T. Basically my average velocity. In this case, my average velocity is my only velocity, which is 30 kilometers an hour. So what do we have? S equals V final in our case, of our velocity, times time. Therefore, time equals S over V, 4 miles divided by 30 miles per hour. I see this is M-I-L-E-S, sorry about that. Miles to miles, that is going to leave me 0.133 repeating hours. So this is my time for A. Now let's look at B. B is up here somewhere, and it is 6 miles. So it has to travel a longer distance in the same amount of time. Remember, the same place, same display, or same location at the same time, my times are the same. I know my time is 0.133 hours. Same equation. This is part B. So I have SB, my distance B is from the bridge is 6 miles. I have a velocity of unknown, and I have a time of what I solved for, 0.133, which I most cleverly stored in my memory location A. So I'm going to give myself some more room here. What's my equation? S equals V times T. In this case, they're all B's. Velocity B, time B, but my time B is equal to my time A. I'm looking for VB. Rearrange SB over TB. 6 miles divided by 0.133 repeating, memory location A, hours. You know what, not much of an equation. 6 miles divided by that time, 45 miles per hour, or 45 mph. So here we are for number 5 of assignment number 2, part B. As you see, I got fancy off-screen and did some little pictures. So here's our bridge. Here's our train B going a velocity of 35 miles per hour south, and it's 6 miles away. Velocity of train A is 30 miles per hour, and it's 4 miles south of the river, or south of the bridge. How far from the bridge do they cross? So I'm going to try and solve this 2 different ways, or solve it 2 different steps. First of all, we need to know when do they cross, or if they're on the same track, when do they collide. And if you remember from our previous conversations, things collide when they're in the same space at the same time. Therefore, our times must be the same. So remember, our time A is going to equal to our time B. And we're just going to call that time for laziness sake. Now, how far is train B going to travel in time T? How far is what is time train A going to travel in that same amount of time? Well, from the handbook we have S equals UA, or the average, times time. Well, being that they're both at constant speeds, we're just going to say that it's equal to our velocity times our time. That's the equation we've known since nursery school. So we have two equations. The distance A travels is going to be the velocity of A times time. Distance B travels is going to equal to the velocity of B times time. Now, however, notice over here that my train B is traveling down, train A is traveling up. We're going to have to dictate which way is positive. Well, if up is positive, then my velocity of A is a positive. However, my velocity of B is going down, it's going to be a negative. So in reality, my SB is going to equal to minus VB times T because of the distance. The other thing is, we need to come up with another equation. We don't have enough equations here to give us everything. Well, if train B is 6 miles from the river and train A is 4 miles, we have 6 and 4. This is going to give us our other equation. Keep in mind this is a difficult question, and I appreciate not everybody's going to get it. What else do we know for these distances? Well, I know that my distance train A travels, because of the sign, minus the distance B travels, equals to 10 miles. Now we have two equations, two unknowns we can solve for it. What we're going to do is we're going to substitute this SA into here, and i.e. these two, and we're going to put this into here. What's that going to give me? VAT minus VBT equals 10. What can I do now? Simple math. I'm going to factor my t's out. I am going to have t times VA minus minus, so plus VB equals 10. Where do we go from here? T, we're solving for t. T equals 10 divided by VA plus VB, 30 plus 35. This is miles. These two are in miles per hour. This gives us 0.1538, storage location A, hours. Now we know they're going to collide in 0.1538 hours. So now we need to figure out where are they going to collide. Well, let's go back up to whichever. Let's look at train A. SA equals VA times T, which is equal to 30 miles per hour times 0.1538 hours. That equals to 4.61538 miles. Please forgive my arrow. What does that mean? That they're going to hit, because it was only 4 miles away from the bridge to start with, they're going to hit 0.61538 miles from the bridge. And being that that's a positive number, that means they're going to hit north of the bridge.